And now we're going to look at converting polar coordinates to Cartesian and from Cartesian coordinates to polar coordinates. Now the main thing to know is if you're looking at a point here, x, y, that means that your distance to the right or left is x and your vertical distance is y. You can draw the line from the origin out to that point, and that's just going to be your radius or the hypotenuse of a right triangle. So now, I know that x value, if I were to take trig functions and write cosine of theta, it would be the x over the r. So that means that the x is just going to equal to r cosine of theta. Well, likewise, let's say sine of theta would be the opposite side, which is the y over the r. So that means that y is going to be r sine of theta. Now notice if you're used to the unit circle, that's giving you the x coordinate is going to be r cosine, the y coordinate is r sine. In this case, the circle here, the r is not 1, but if the r were 1, you would see that the coordinates of the point would be cosine theta comma sine theta. Okay, so now the coordinates of this point are either x, y, or they're the r theta. And the relationship between the r and the theta and the x and the y are given by these formulas. So x is r cosine and y is r sine. So if you're given r and theta, you can use those formulas to get the x and the y. Now let's say that you're given the xy coordinates and you want to find the polar coordinates. So you need to find the r theta. Well, you can easily get the r by just using Pythagorean theorem and getting what that hypotenuse would be. And the theta, you're going to use the tangent function. Tangent of theta is going to be equal to y over x. So to find the angle theta, you can just solve that little trig equation. Okay, so let's convert some points. We're given the Cartesian, the polar coordinates 2, 3 pi over 4. So if you were to graph it, I would go around 3 pi over 4, so this would be my terminal side, and my distance away from the origin would be 2, so I'd be moving this direction. So this is the point 2 comma 3 pi over 4. Now one thing that you've got to do when you're looking for these coordinates is you've got to graph it. You've got to see where the point actually lies, which quadrant. Okay, so now I'm looking for the x and the y. I know that x is equal to r cosine of theta, and the y is equal to r sine of theta. So just plug in r equal 2 and theta equal 3 pi over 4. So I'm going to have 2 times cosine of 3 pi over 4, and then 2 times sine of 3 pi over 4. Well, cosine of 3 pi over 4 is going to be negative, the same thing as cosine of pi over 4, so that's going to be negative the square root of 2 over 2, so this is just going to be negative the square root of 2. Sine of 3 pi over 4 is the same thing as sine of pi over 4, and that's square root of 2 over 2, so this is just going to be the square root of 2. So our x, y coordinates for this same point then would be negative the square root of 2, which is 1.4, and then positive the square root of 2. So the same coordinates, just different coordinate system. Okay, so now let's look at the Cartesian coordinates 1, negative 1. Okay, so if I were to plot them, I know the points down here. Okay, so this has coordinates 1, negative 1. Now find the r and the theta. I know r squared is the x squared plus the y squared. And my x was 1 and my y is negative 1. So that's going to be 1 squared plus negative 1 squared. So that's just going to end up being 2. That's r squared, so that means the r will be the square root of 2. And you could use a positive or a negative r. In general, we usually just use the positive one. Okay, so now I know the distance from the origin is the square root of 2. So now let's determine the angle. I know that tangent of theta will be the y over the x, which is negative 1 over 1, or negative 1. Well, the angle theta that has the value of 1 has a reference angle of pi over 4. Okay, I know the 1 occurs for tangent function when the reference angle is pi over 4. It's negative, which means it's either in quadrants 2 or 4, since tangent's positive in 1 or 3. So now you've got to determine which one is it. Now there's more than one way to give those coordinates. I could give this point, I know the reference angle is pi over 4, I could have said negative pi over 4, and if I'm moving this direction, the reference angle would actually, the terminal side would be moving in that direction, so I would have to have a positive, the square root of 2 for the r. That's one way to describe it. Or if I want to use the fact that it's in quadrant 4, I could come all the way around and say that this angle, from the x-axis, from here around would be 7 pi over 4, and the terminal side again would point that way, so the square root of 2, 7 pi over 4 is another way to give it. And that's the more common way that you'll give the answer. Another way you could give it is we could use an angle that's in quadrant 2. So we could use 3 pi over 4 and recognize that this is just the opposite direction of the angle going in that direction. So this would be 3 pi over 4, and that's where the arrow's pointing out for the second quadrant. And so if we want to use a point, identify a point over here, right here, in quadrant 4, we would have to use the 3 pi over 4 for the angle, but with a negative r. So most likely this is the one that you'll expect, but notice I had to plot that point in order to see that it really was in quadrant 4. Otherwise, I didn't know what angle to give it. So whether to give it an angle in quadrant 2 or quadrant 4. So plot the point, and it's especially important when you're going from Cartesian to polar coordinates.